All right. One more law. One more law. However, before we do law number 3, okay, before we get to law number 3, there's one thing I need to talk about, okay? There's one definition that we're going to need, okay? And that definition is for a special unit in astronomy, okay? So check this out. What's a typical distance unit? Give me any distance unit. Don't worry about space. Don't worry about space. Like if I wanted to know how far apart my hands were, what's a distance unit I could use to talk about? Well, miles is a good one. Yeah, miles is a good one. Feet, centimeters, meters, kilometers, yards. Those are all good distance units to use in everyday life, right? But why are miles and kilometers even not a good thing to use for distances between the planets? Why is it going to be a hard thing to do to use miles or kilometers for distances between planets? Yeah, they're way too far apart, right? They're way too far apart. Does anybody know how many miles the sun is away? The sun's actually not considered to be that far away in astronomical terms, but does anybody know how many miles the sun is away? Sometimes people know it. I don't really expect anybody to. Nah, it's okay. It's about 93 million miles, right? The sun is 93 million miles away. And we're not the closest planet to the sun. There's planets that are 20, 30 times further out. Okay, so if we want to use miles or kilometers, we would have to use giant numbers all the time. And we don't like to do that. So in astronomy, we actually came up with a few different units for talking about distances in space. And I want to go ahead and talk about 2 of them real quick. 2 different units we use in space. Now, the first one has a super boring name. It's just called the astronomical unit, okay? What's a unit we use in astronomy? The astronomical unit. Let me write that down up here. Astronomical unit. Which is usually abbreviated as AU. Capital A, capital U. Astronomical unit. So this is a much bigger unit than a mile that we use for talking about distances between the planets. But units have to have something as their standard, okay? Something has to be the standard. In other words, it has to be defined as something, okay? And so what is the standard for distances between planets? Well, we picked one of the planets to be the distance between that planet and the sun was the standard for astronomical units. Anybody want to take a guess what planet we chose as the standard planet? Take a guess. Which planet's the standard planet? We picked Earth. We picked Earth. Why did we pick Earth? Why would we pick Earth over other planets? Pretty simple reason. Yeah, because we live there. We live there, and yeah, humans are kind of self-centered. So, here we go. 1 astronomical unit is the average distance between the Earth and the sun. Okay? 1 astronomical unit is the average distance between the Earth and the sun, right? Why do I have to say average? Why can't I say an astronomical unit is just the distance between the Earth and the sun? Why do I have to define it as the average distance between the Earth and the sun? Why's that word average got to be in there? Yeah, like we were talking about in law number 1 and law number 2, planets are sometimes closer and sometimes farther away. So we take the average to be the standard for the unit. And that means that instead of saying that the Earth is 93 million miles away from the sun, we can just say that the Earth is 1 astronomical unit away from the sun. And that's a much easier number to deal with. And the planets that are closer to the sun, like Mercury, Mercury is about 0.4 AU. Mercury's closer to the sun, so it has, like 0.4 AU. That's not a hard number to understand. Does anybody know which planet is farthest away from the sun? Which planet's farthest away from the sun? Remember, not Pluto, because Pluto's trash, right? What planet's farthest away from the sun? Don't worry if you get it wrong. It's okay. Neptune. It's Neptune. So Neptune, the farthest planet from the sun, is on average 30 AU. Whoa. 38. There you go. 30 AU. Okay. Let me restart this. So that's a much easier number to deal with than these giant, ridiculous amounts of miles. That's the farthest planet away from the sun. So the biggest number we're going to deal with planets is just 30. Way easier to understand. There are a few things that are farther out than the planets in our solar system. There's a bunch of comets that go much further out. But typically, you don't get things orbiting around our sun much further than about 100 AU. So the biggest number that you have to deal with is just 100, okay? Now, here's the one other thing I got to say here, though. What would happen if I tried to use astronomical units to tell the distance to the closest star? Remember when I was talking about the space between the stars a couple of other times? Would I want to use astronomical units to do distances between stars? No. Why not? Why would I not want to use astronomical units to tell distances between the stars? We run into a similar problem that we talked about a little while ago. Yeah, I think you guys are getting it. Some people are trying. I'm going to give you just a second here to give that a chance. Stars are actually too far apart, okay? So just like it was hard to use miles for distances between the planets, so we actually had to come up with astronomical units to have easier numbers to work with. The closest star to us is over 60,000 astronomical units away. And that's just the closest one. Most of the stars out there are millions and millions of astronomical units away. So if we tried to use this for that, we would actually run into the same problem where we don't like to deal with these giant numbers, right? So instead, we came up with another unit. And this one's very popular. You probably have heard of it before. Does anybody know what the other main unit that's used in astronomy is called? I think you guys probably have heard of it. What's another unit that's used in astronomy? Yeah, light years. Light years. So we're not going to see light years for a while, but I just wanted to go ahead and get it out right here. So check it out. Light years. What is a light year? Well, there's a bit of a problem with the word light year. The word year is a unit of time, so a lot of times in sci-fi movies, they'll use light years as a unit of time. Like they'll have an alien show up and he'll be like, oh, my age is 45 light years. I'm 45 light years old. That doesn't make sense. This is a distance unit like meters or miles. That would be like a human being saying, oh, my age, how old am I? My age is 45 miles. I'm 45 miles old, right? That's yeah. They do that in sci-fi movies all the time. But yeah, so this is a much bigger unit. We use astronomical units for distances between planets or things in the solar system. And we use light years for distances between stars and galaxies and anything bigger like that. Okay, so what is a light year? Well, it has something to do with a year and something to do with light. And it has something to do with a special property of light that we haven't talked about yet. Check this out. Special property of light. There's something very special about light speed, okay? Now, a lot of people know that light speed is very, 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 very fast, but that's not the most special thing about it. Does anybody know what's special about light speed? It's a very important property of it. That's okay. I'll just tell you guys. It's constant, okay? All light goes the exact same speed, no matter what, okay? All light goes the exact same speed, no matter what. So if we had like a light race, like if you and me had like a flashlight and we were just and just shot some light out, it would go the exact same speed and we would have a tied light race. And so you guys are getting this here. What a light year is the distance light travels in a year, okay? The distance light travels in a year is a light year. I don't actually have to say average that time. Why don't I have to say average? I can just say the distance. Why don't I have to say average? Why can't I just say the distance light travels in a year? Yeah, it's because of that constant speed. Because the speed of light is constant, every single time light will go a light year in a year. So how big is this? Does anybody know how long it takes light to get to us from the sun? That's actually, sometimes people know that fact. Does anybody know how long it takes light to get from the sun to us? This is light coming to us from the sun. Okay, nobody's guessing this time. It's 8 minutes, okay? Even though light is ridiculously fast, it can travel 93 million miles in 8 minutes. Takes 8 minutes to get to us from the sun. Oh, so some of you guys guessed roughly right? Now, check this out. If light can go 93 million miles in 8 minutes, we know a light year is bigger than an astronomical unit, but is a light year a lot bigger than an astronomical unit or just a little bit bigger than an astronomical unit? Is a light year a lot bigger or a little bit bigger? It's a lot bigger. Okay? It's a lot bigger, actually. Because check it out. I just said that the light can go an astronomical unit in 8 minutes. Because it takes 8 minutes to go to us from the sun, right? And if it takes 8 minutes to go an astronomical unit, a light year must be very, 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 very big. Okay? So keep that in mind. If we want to talk about distances inside the solar system, we use this. And outside the solar system, we use this. 1 light year. That's LY. Okay.